Hi, welcome to the Ask Academy. Today we're looking at factoring by grouping. So if you see a polynomial that you want to be able to factor and it has four terms. So I'm going to give you an example of that where you have factoring by grouping is the method. You recognize you know to do grouping when you have four terms as this example. We have four terms here, so we're going to group them up this way. We're going to factor by grouping in this fashion. We're going to take the first two terms and we're going to group them up with parentheses. We're going to take the next two terms and group those up by parentheses, except that when this third term is negative, I need to be careful in doing that, because when I drop parentheses, as you saw me do here, I created an algebraic problem. Distributing that negative through, now the 48 is going to be positive or negative when it was originally positive. So I want to make sure that that third term is negative, that I'm careful about taking that negative with it inside the parenthesis, so I maintain the negativity of that 48 as well, or the positivity, or whatever sign it happened to be. I don't change it. So I've got that grouped now. What I want to do is look at each of the individual groups and factor common terms out of each. So I'll focus on these two, and I see that common terms of x squared can be factored out of each of these two terms. So I factor that out, leaving what I have inside that when I factor it out. Now look at the other group, and I factor out common terms that I see in each of these, and I see there that I see 16. So I'm going to factor 16 out of that, leaving negative x plus 3. Now here's the hint for when you do this factoring by grouping. They're going to give you problems set up so that what you have left inside the parentheses are going to be absolutely identical. In this case, it's not. So when you don't see that, identical binomials, when you do the factoring of the groups, you know you need to look at what you factored out. Instead of factoring a positive 16, I could have factored out a negative 16 out of both of these, because each will divide equally as well, which would just change the signs of these two terms inside. So negative 16 times x is still negative 16x. Negative 16 times negative 3 is still positive 48. So I factored correctly. I just needed to factor it in a way so that I'd have the same binomials. Now, the next step is rather confusing to most learners. So let me give you something that you've already should be familiar with and should be a little easier to see. As an example, if I have x squared times 7 minus 16 times 7. Now I know you've seen that before, and I can ask the question, what's common in both of these terms? You would say, right, 7. And I can factor that common thing out. If I factor 7 out of this, I'm left with x squared. 7 out of that, I'm left with negative 16, right? That's easy to see, that's simple and not confusing. Well, I want you to relate that to what you see here. Here, you see x squared being multiplied not by 7, but by x minus 3. And you see negative 16 not being multiplied by 7, but by the same thing, the same factor, x minus 3 in both. So like you factored the 7 out, you can factor the x minus 3 out. And when you factor an x minus 3 out of this, you're left again with x squared, just like that. And then with negative 16, just like that example. So hopefully connecting to something you're already familiar with helped you see something that might be a little bit more confusing. Well, now we have this factor, x minus 3 and x squared minus 16, but is it factored completely? You need to start looking at, keep your radar out, to see if you see common patterns that we've been introducing you to. This is the difference of two squares. So I know I can factor that. Difference of two squares, square root of the first one, square root of the second one, 1 plus, 1 minus. It doesn't matter which you write first. That is factored correctly. That is factored completely. 3 factors. 1, 2, 3. Third degree. See the clue? Hey, we are the Ask Academy.